All right, so this is my importing here, this 401k data set. Bring it in. The first question is just, and one thing that I add here, and I'll put this code online so you can look at it. One thing that I find helpful, especially if I'm writing a report, is to use this this ODS command here. So it's kind of this part and then this part down here. And basically that exports all your results into, and here I have it for an Excel file, but you can also do it for a Word file or whatever you want. So this will take the results and export them into an Excel file, and then you can do whatever you want with them there. And this is just basically the file path, and this is for an Excel file. So I think there's a different set of commands if you want to do it for Word. So a lot of times if you want to put, you're typing up your results and you want to put your results in a table, and you want to write about it, this is one way to do that. Okay. All right, so the first question, let's see, asks you to, what are the sample means? And that's fairly straightforward. We just do a proc means for that. We can get all the means we want there. Second question, plot P rate versus M rate. And so here I use proc gplot. If you use proc plot, you get these big asterisk points, but here you can kind of see it a little more clear. And so participation rate, remember, is the binary dependent variable. Well, it's not binary, but it's bounded at 100%. So you obviously can't have a participation rate higher than 100%. And generally, these participation rates are pretty high. At Texas Tech, they do some kind of matching. It's about a 1-to-1 match, and so we'd be about right here. So you put in $1 towards your 401k plan, they put in $1. Usually they're kind of nonlinear. They're not just whatever you put in will match it, but they match some amount. And so here it's obviously bounded at 1, which actually is not an issue that we'll get into this semester, but this is an issue of sensory, which is an issue that comes up next semester. So the question is, how do you deal with that, the fact that you have a bunch of those? Because if you're trying to fit a line, you're probably going to fit it either like this or like this. But sensory actually does pose some problems. So another example could be if you have like a price ceiling, and you don't observe prices above a certain level, then you can use these sensory models to actually see what the relationship is. Okay. Anyway, there's the plot, and obviously it looks like it's a positive correlation, right? With some censoring up at top. Part C asks you to construct a confidence interval, so you can do that a couple different ways. The way that I did it was just this with the CLB command. And so you get your confidence points right out there. The other way you can do it is obviously just to calculate it. So then you would take, this number plus or minus your standard error times your critical t-value, which I think is 1.96, and then you would get your confidence interval. All right, interpreting words with the intercept and slope estimates. So here, remember, we're trying to predict participation rate. And so if there's no match, then we would anticipate about 83% to be involved with the retirement plan. And then as the match rate goes up by as it goes from 0 to 1 or 1 to 2, we see that participation rate increases by almost 6%. So our expected value, if the match rate was 1, would be about 89%. Question F has you estimate, given that match rate is 3.5. And so for that, you're just going to use your parameter estimate. So you take beta 0 plus beta 1 hat times the 3.5 to get your predicted value. variation, right? So G is just asking you about R squared. Just remember what R squared is. Okay, so now we estimate a linear regression, and so again, we're just adding another variable here. Sole, is this the sole option there? And so we can run this regression. And again, everything comes up significant. So, if it's the sole option, then obviously that has an impact as well. So you can add an extra. It's basically an intercept shifter, right? So if it's the only option, then it shifts everything up. Even if the match rate is 0, the intercept is at about 80, 85. Now, one thing that the next questions get into is the fact that, notice that this beta 1 is 5.49, and this is 5.86, right? So it changes a little bit. So on the same value, it changes a little bit. So if you remember back, we talked about the difference between a multiple linear regression and a simple linear regression. So if we have y as a function of right, and so we have a single linear regression and a multiple linear regression, and these are all hats, and these are all tildes, right? Just denoting that they're different. We would get this relationship that beta 1 tilde was equal to beta 1 hat plus beta 2 hat times this delta 1 hat, right? Where the delta 1 is going to be from this other regression that we're going to talk about. The regression between x2 and x1. And so if we do that, this is kind of the next one. So if we regress x2 on x1, so we're regressing sole on the match rate. So we have so we have this regression there. So we have these 3 regressions that we're going to use, and I've kind of said that this is going to hold, and you can actually add these together and get back to this result if you kind of do this. Let's see what there's numbers here. So if you take these values, so beta 1 hat is 5.49. Plus 4.09 times, I think, this one's so this is from the third regression. Yeah, this is 0.9. Then you should get about to this 5.86. So this is going to be about equal to 5.86. So this is from the linear regression. These are from the multiple regressions, and this is from x2 on x1. Okay. So that's kind of the relationship that we talked about before. So why does beta 1 change? Because there's this indirect effect through x2, right? So there must be some correlation between x1 and x2. So because there's some correlation between those two, we have, even though small, right, 0.09, it's statistically significant. And so because that's non-zero, and because this is non-zero, we get a difference between these two. Okay. That's all I have. Okay. Any questions on the SAS part? All right. So I'll put that online too, so everyone can see that. Okay, and then question 2